Welcome back to Spring Into Math 5. This is Mr. Stein here with you again, and today we're going to wrap up Chapter 9 with our review. Okay, so the first thing we're going to talk about is understanding line plots. And like always, remember, these reviews are a little bit faster than the traditional video, so if you need to go back to those lessons to get a more clear and concise version, do so. So here we go. So we talked about what data is, and we talked that data is usually numbers connected with real life situations. So if we're going to count how many people came to the amusement park like we did already, the number of people that we counted would be the data that we'd be collecting. Now, what does it mean when we organize data? So organizing data means to organize numbers from the real world information from those situations. Now, for instance, if we use the example that we talked about with the amusement park, we would be taking the counts of the number of people who visited the amusement park and writing them in a way that's easy to read. So, let's talk about making a line plot, which is a way to organize data. So, a line plot is the display method that we can use to organize data. So a line plot shows how many times each number appears in a data set. Instead of putting the information into a table, however, we use a number line. All right, so line plots are especially useful when the data falls over a large range. So let's take a look at a line plot and kind of look at how we build one. So the data represents the number of students that each were in a class at a local community college. So you guys will probably remember this just from a few days ago. So we had our range from 30 all the way up to 41, and each time they took account of how many people were in the class, they recorded the number. And you can see here it's organized in numerical order. Now, if we look at the data, we can make a couple conclusions. Like I said, we have a range from 30 to 41, and then a little bit, if you dig deeper, you don't have any classes of 32, 34, 35, 36, or 39. And if I slide back and we just look at that range, it's not the easiest to pull out the numbers that are not there. So keep that in mind as we look at the actual data on a line plot in a moment. So building a line plot involves counting the number of students and then plotting the information on a number line. So we use X's to represent the number of classes that each number of students is in. So let's look at this line plot. So now when you look at it, you can clearly see how many classes there were, not how many classes had no people, but that there were no classes of 34, 35, 36, or 39. Because when you look at it on a line plot and you don't have an X, it's very clear which numbers are not represented in our data set. So, like I said, notice that we didn't have any classes with 32 students in it, but that we included it on the number line so that you could see that that it's not reflected there. And that's a really important thing, and oftentimes students want to leave that out. So make sure you include the numbers, even if there's no X there, even if it didn't occur in your data set. So each value of the range of numbers needs to be represented even if the value is 0. So when you look at 35, for instance, we have a 0. So you can see that there's no classes that had exactly 35 students. Okay, so now let's use this line plot to answer some questions. So how many classes have 31 students in them? Well, you can look here, you can look at the line plot. I'll just highlight it real quick, and you can see that there were 3 classes that had 31 students in it. Okay, so how many classes have 38 students in them? So again, go to 38 and just kind of highlight it. You can see that there's 1X, so there was one class that had 38 students. So how many classes have 33 students in them? So again, you just identify what the number 33 is and count your X's, and there's 4 X's, so that means there's 4 classes that have 33 students in it. All right, so how can we make a line plot when our data is unorganized? So unorganized data is data that is just not written in numerical order. So another way to think about it is it's data that's all mixed up. The numbers are just kind of everywhere. So let's look at an example. So we have Jeff, and he counted the number of ducks he saw that were swimming in a pond each morning on his way to school. So you can see here he just kind of took a tally as he walked by, counted 6, and the next day 8, the next day 12, and so on. So you can see it's a little bit harder to represent, to see our range and to see what day, what numbers are missing. So Jeff's data is unorganized. It's not written in numerical order. So when we have this unorganized data, the first thing we do is we organize it into numerical order. Now obviously I have the mixed up data on the other slide, but if you're looking at it and you're looking at working on a problem, you're looking at the numbers, you just rewrite them, and I like to cross them off as I go and organize them from least to greatest. So then the next step is to make a line plot. Okay, so you take our data points, 6 all the way up to 14, so that's our range, 6 to 14. So if I'm building my number line, I start with 6, end with 14, and then I put every number in between, even if there's no number represented in my data set. And so you can see here, you know, the frequency of 6 ducks was the highest, so that he saw 6 ducks 5 times, and then you can see that there were no days when he observed not only 9 ducks or 10 ducks. Okay. So now let's talk about using line plots to gather information. So how do we read line plots? So the following line plot shows data regarding the number of people who attended different movies in 1 week. So let's use the following line plot to answer some questions. Okay, so you have our line plot. You can see here that I have a range from 21 to 28. And remember, this is just recording, you know, the number of people that attended a movie. Okay, so if we were to create a list of this data, is the following list correct or incorrect? So a couple ways to do this is obviously you can just kind of tally as you go. You look at 21, make sure that it is accounted for 2 times. But something that you might use to kind of, you know, to do it is you could also see like 25 and 26. Well, there should be no 25 and no 26 because there's no X's on the line plot. And so you can see here that I have a 25 and 26 right there in the middle. So you know for sure that this data set is not a reflection of the line plot that you see. Okay, so would you consider the list in number 1 to be organized or unorganized data? So you can see here I have 21 up to 28. It's in numerical order so that it is organized. And then if we're talking about explaining the difference, remember, organized data is written numerically and unorganized data is just not written numerically. It's mixed up. The numbers are kind of scattered throughout the number line. Okay, so now let's answer some different questions. How many showings had 25 people or more in attendance? So a line plot's a good way to do this. You just look, I see there was no movies that had 25 people or 26, but there was 3 that had 27 and 2 that had 28, giving us 5 showings that had 25 or more people. And keyword there is or more. Okay, so how many showings had less than 25 people? So I'm just going to kind of do the opposite. And a good strategy that I like to do is just kind of counting by 2s. It's a simple way to skip count, and it makes it a little bit faster. So I got 2, 4, then I got 6, 8, 10, and then 11. So I had 11 showings that had less than 25 people rather. Okay, now let's answer some true or false questions. This data also tells you which showings had the most people in attendance. Well, this does not tell me which showings had the people in attendance. This is just telling me the frequency of showings that had a set number of people. So I can see that, you know, it tells you 24 people is the amount of people that came the most often, and 28 is the one that had the most people, but it doesn't tell me which showings. Okay, so true or false? There are 2 showings that had 27 people in attendance. So I look at 27, I see there's 3 X's, so obviously that's false because it said here that it said only 2, but in reality there were 3. Okay, so here's a line plot that shows how many seals came into the harbor in La Jolla, California during the entire month. So you can use it to answer the following question. So you can see here I have a range from 30 to 70. All right, so how many times did 30 seals appear on the beach? You can see that it happened 2 times because I have 2 X's over the 30 on my number line. It says, which two categories have the same frequency? Well, the same categories would be having it happen 2 times and having it happen 3 times, or having it 1 time, excuse me. All right, so how many times were there 50 or more seals counted on the beach? So again, it's 50 or more, so you're just looking for 50, 60, or 70, and it happened 1 of each, so it happened 3 times. True or false, this line plot shows us the number of seals that came on the beach each day of the month. That's obviously false. It doesn't say anything about the days of the week or how many times it happened during the month. This is just telling me frequency of large numbers. Okay, another true or false question. There weren't any days with less than 30 seals appeared on the beach. And on this, that's going to be true because on the number line, there's nothing less than 30. Okay, so now let's talk line plots with fractions. Okay, so reading and creating a line plot with fractions is similar to a line plot with whole numbers. So here's one with fractions. So we're back to our idea of trail mix bags. Okay, so you have my line plot from 0 to 1, and then you have your fractional increments in between. So you have a fourth, a half, and 3/4. So the line plot shows the different amounts of bagged trail mix that Sam bought at Vons. Now, how many pounds of trail mix did Sam buy? So we're going to use the line plot to formulate an answer. We're gonna basically add up all of those different numbers. So we can see that Sam bought 3 1/4 pound bags, not 3 1/4, but 3 1/4 pound bags, 2 1/2 pound bags, and 2 3/4 pound bags. So what we're gonna need to do is add these all together. So remember a little tip we talked about last time is kind of refreshing your memory on fractions. You gotta have your denominators to be the same. They have to have like denominators to add. So first we need to make all of them the same. So we notice that a 1/4 and 3/4 have the same denominator 4, so we don't have to do anything with that. So we really just have to make a 1/2 have a denominator of 4. And a good relational idea and spatial sense of equivalent fractions will tell you, well, 2/4 is also equal to a 1/2 because 2 is 1/2 of 4. So if we just change our fraction of a 1/2 into 2/4, we can easily add our fractions. Okay, so if we reflect them with like denominators, you can see that I have my 3 1/4 pound bags, 2 1/2 pound bags listed as 2/4 now, which is the equivalent fraction to a 1/2, making 4 the denominator, and 2 3/4 pound bags. And so if you add them all up, you get 13/4. And then of course we want to change that number to a mixed number to kind of give us a better sense of how much weight we have in pounds. So then I have 13/4, so then I have 13 divided by 4 is 3, because 4 goes into 13 3 times with 1 left over, because it really goes into, it can go into 12. 4 is a factor of 12. And then so I make my mixed number with 3 as my whole number, and then I have 1/4, so 3 1/4 pounds of trail mix. Okay, and if you recall from our lesson last time, we also talked about that real world situation with my daughters Samantha and Abby, so just keep in mind you might kind of get some of those ideas as well. But we're going to wrap up chapter 9 with that. But keep in mind, really take a long look at those fractions those line plots and use your data. See you next time.